Okay guys, so this question appears in almost all your March question papers. So in this video I'm just going to show you how to solve it, right? So it's usually given 2 marks to solve this kind of question. Indicate between which two consecutive integers does a certain number, in this case square root of 47, lie. So to understand what this question wants of you, you need first to know what does consecutive mean, right? Consecutive simply means numbers that follow each other, and integers is some kind of numbers which integers is some kind of numbers that belong in a number set, right? So let's take a quick look at what the number set is. A number set is a Venn diagram, essentially. Venn diagram is just some diagram represented in circles, yes, whereby some other things they overlap, meaning some things they fall on this side and also on the other side, right? So overall numbers, all the numbers that we have in mathematics, we call them complex numbers, right? So the more you go inside is the more you get more specialized numbers, right? But each and every number fall within the complex number system. So for example, you have imaginary numbers here. You have your imaginary numbers here. Let me do this. Let me add this thing here, right? So okay, let's do it like this. Right. Let's move it down like this. Yes, so you have here, these are your imaginary numbers, right? And then they all fall under what? A complex number circle. Each and every number that you have in mathematics, whether it's a fraction or whatever, it falls under a complex number, right? So you have imaginary numbers. You're not gonna have to worry about imaginary numbers as of yet when you're in grade 10, right? So we're gonna avoid the imaginary numbers, and within the complex numbers we have imaginary and real numbers, right? So these are your real numbers, and they are represented by what? By R, right? Imaginary numbers are represented by I, that has 2 strokes, and real numbers are represented by R, which also have some kind of 2 strokes on the left, right? Inside the real numbers you have your irrational numbers here. You also have your rational numbers here, and as you can see, your irrational numbers are a Q that has something at the top there, and then your rational numbers, your rational numbers are just represented by a Q like this, right? So you need to remember this diagram when you're in grade 10, because most of the questions that you'll get on your question paper, they will be somehow based on this diagram. So let's go on. So basically we start in real numbers, whereby we have rational and irrational. Irrational numbers are numbers that cannot be, that are written like this, right? The square root of 10, square root of 2, negative square root of 8, or pi. So basically these are the numbers that you get as 3, 0, 1, 4, 6, blah 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 blah, right? the numbers that have commas, that goes on and on and on and on and on. So let's see if square root of 10 has a comma and some other numbers next to it, right? So I've opened my calculator here. This is a normal Casio calculator. You can use your normal Casio calculator, and then you click on the square root thing, and then you can write 10. You say equals to, you press SD just on top of delete, right? And then you see now you get 3,16 blah 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 and so on and so on. All the irrational numbers are categorized by this type of expression, that's how they look. Like for example, your pi is 3,14 something. So to see pi, you're gonna press shift right on top of on this shift button. On this button there is a shift that's written in yellow. So when you click this button, whatever that's written in yellow will be clicked. So for example, if I press it and then I press on the X10, if you look on the X10, there is a yellow pi, a yellow symbol there. So if I click here, I'm gonna get that symbol, and then I say equals to, I press SD, I get 3,14 blah 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 blah. This kind of numbers which have a comma and they go on and on and on and on and on are called irrational numbers, right? They're called irrational numbers. They can never be written as a fraction, right? So because it goes on and on and on and on and on and on. Notice on the rational side of things, you have negative 0,25. Well, you can ask me, is this not an irrational number since it has comma, so forth? But the thing is, the comma does not just go on randomly, right? The comma has a where it ends. Like for example, your 3.5, it's 3.5, and negative 0.25 is actually negative 1/4, and this is actually your 7/2, right? So let's use a calculator and see. Let's say okay, let's say minus 2 point, okay, minus 0.25, right? Equal to, see, you get minus 1/4. This is a fraction. An irrational number cannot be written as a fraction, and a rational number can be written as a fraction. Just put that in mind. And 3.5, you're gonna get your 7/2, right? Cool. Just remember that. Inside your rational numbers, you have integers. You have integers here. These are your integers here. What are integers? Integers are any numbers that does not have comma, something something something, that goes on and on and on and on, and they start from negative infinity up until positive infinity, right? Integers, actually, they don't have a comma at all. Integers are numbers that start from negative 500, negative 400, negative 399. They just don't have commas at all. Once they have commas, they either rational or irrational, right? So your integers, they start from negative infinity. Negative infinity is where we don't know where the numbers begin. Basically, we just give it an infinity. If you go on backwards until wherever, we just give it negative infinity. And positive infinity is where the numbers have where they end. All right, so yeah, positive infinity also means that where the numbers end in the positive side, we don't know where they end actually. So when we go deeper inside integers, we have whole numbers, right? And by the way, your integers are represented by this sign. So you need to be able to remember these symbols, right? Remember, complex numbers is C, remember complex numbers is C. Imaginary numbers is this I here, and real numbers is this R of this sort, and irrational numbers is Q that has this thing on top, and then you have your rational numbers, which is just Q, and then you have your integers, which is a Z. Almost all of these symbols, they have some kind of strokes to them, but you don't have to worry about the strokes because you just intuitively know. Okay, so when we go inside the integers, we have what is called as whole numbers. Whole numbers, they start from 0 up until positive infinity. So whole numbers are your integers except from negative numbers and so forth, right? So they are represented by W of this kind. And then you also have, lastly, you have your natural numbers. As the name suggests, you know, in nature you cannot count things in negatives. You always start at 1. So your natural numbers start at 1. So please make sure that you remember this thing. You do it again and again when you practice, because some questions will come and they might give you this symbol here and give you a question, and they just put this symbol here. You need to know it's a natural number, right? So just make sure you practice these things, and then you remember them for your exam, right? So let's go back to our question. The reason why we went to doing this diagram is because here they said integers, and right now you can see, okay, our integers are each and every number from negative to positive, right? And it doesn't include commas at all. So then that means they want some number here and some number here, two numbers, some number here and some number here, which are actual numbers. They don't have commas, they just straight up numbers. They either positive or negative, right? So to easily find this number, to easily do it, the easiest way to find this number, that these two numbers that they want and get these 2 marks here, let me write this on a clean page. It's square root of 47, right? We can try square root of 46 and say equals to, so we're gonna use our calculator, right? We say square root of 46. As you can see, square root of 46 gives us 6,782 blah blah blah, right? This is not an integer, right? It's actually an irrational number, it's not an integer. So let's try square root of 45 equals to, let's see, square root of 45 equals to, okay, let's say square root of 45 equals to, still we get 6,7 blah blah blah. It's also irrational, it's not an integer, so we don't want it. So let's try square root of 44, square root of 44, square root of 44, still it's an irrational, right? Square root of 43. I'm just going to use the calculator from now on, right? Square root of 43 equals to, it's an irrational, as you can see. It's not an integer, it's not just 6, it's 6 point something, right? And let's try square root of 42, 6.48 blah blah blah, right? This is not what we want. Square root of 41, same. Square root of 40, same. Square root of 49, it's 7. Oh man, we are going down. So square root of 39, I mean 39, we get 6.2. Square root of 38, we get 6.16, blah blah blah. That's still not an integer, so you won't get a mark for that. Square root of 37, we get 6.0827, and so forth. Then let's see square root of 36, then boom, you got a 6. Is 6 part of the integers? Yes, 6 is part of the integers. So now we know that square root of 47, going to the left you have 6, and let's see what we get when you go to the right. So we're going to say square root of, because we have 47, square root of 48. It's irrational, as you can see. Square root of 49, we get 7. So from these things, and you can see that, remember the question said consecutive, meaning that these numbers have to follow each other. So you can see that 6 and 7, they do follow each other, right? And they are integers. So you're gonna get 2 marks for this. 1 mark for that, 1 mark for that. In some papers you can just write it like this. You know the greater signs, a greater or equals to sign. So you have your 6 and you have your 7 here. This is to say square root of 47 is greater than 6 and is also less than 7. These are your 2 consecutive integers. Right. So as you can see, this process is very long. So we want to do things the easiest way possible, right? We want to do things the easiest way possible. So to do things the easiest way possible, whereby we can get our answer easier than this long process whereby we have to test going down, you can simply just use the things called the perfect squares, right? What are the perfect squares? Perfect squares are numbers that when you multiply 1 times 1 you get 2, 2 times 2 you get 4, 3 times 3 you get 9, and 4 times 4 you're gonna get 16. 5 times 5 equals to 25. 6 times 6 equals to 36, right? So basically your perfect squares are numbers that you multiply by themselves, right, and you get something. So this is what you would usually do to solve this question the easiest way. You have square root of 47, right? When you have square root of 47, you come to your calculator, you put it in a calculator like this, square root of 47, and then you're gonna get 6.855 blah blah blah. So that means to go this direction to get an integer, 6 is your perfect square, right? Because you have 6.8, right? So you're gonna take 6, which is square root of 36, right? You say, okay, to get a number that is consecutive to this, I have 6.8. So basically you have 6.8 556 blah 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 blah, right? So here you have your 6, and then here you have your 7, right? You just know this number, whatever the square root of 47 is, it lies between 6 and 7. As you can see, when we put it in the calculator, it is less than 6 but is greater than 7. So you're gonna write like this. So you're gonna write like this. You're gonna say, okay, square root of 47 is the same as 6 times 6, right? 6 times 6 is 36, which is the same as square root of 36. See, and then it's also less than square root of 7 times 7 is 49, right? And then you have your square root of 47 here, which is less than 6, but which is greater than 6, but is less than 7. Simple as that, right? You get your full 2 marks if you do this. Just put that in a calculator, check, is it between 4 and 5? If it's so, let's try square root of 63, right? Let's put square root of 63 in a calculator like this. Square root of 63, we get, it's an irrational number. As you can see, it says, okay, it's 7.937, right? 7,937, blah 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 blah, right? We are in this corner, ne? So right away, you know, 7.9 blah blah blah, this is definitely greater than 7, but it's less than 8. So these are your actual consecutive 2 integers. But to make sure that you get full marks, you're gonna write it like this, right? 63, and then you're gonna say greater than, what is 7 times 7 is 49. What is 8 times 8 is 64. You can use a calculator to check. You have 7 times 7 equals to 49. So you put it in a square root like this, and then you're gonna do the next step, 63, and then you're gonna say 7 and 8. Where do we get the 7 and 8? We just looked at what the square root of 63 is when we press SD, right? Please don't forget, this is the easiest thing you can get the marks for. Let's try square root of 70. Let's see where it falls. First of all, you grab your calculator, you say, okay, 70 equals to, you get 8.3. You know, definitely 8.3 and whatever is greater than 8, but is less than 9, right? And remember, this question is always, they are more likely to ask you consecutive meaning or they follow each other, né? So it's 8 and 9, but because as you can see, this method is like you're cheating it, which you can say you are, but if you know what you're looking for, then it's technically not cheating. So you want to show them you know your story. So cheating is allowed in an exam if you can cheat the right way. So you say 8 times 8, which is the same as 64, and then you say 70, and then you say 9 times 9, which is the same as 81. Let me just put 64 here. What's this thing? 64 here. So this is actually not cheating. It's not like you're cheating. You're just finding a better way of doing this, because in order for you to reach to 64, you need to minus 1 for 6 times, and in order for you to get to 81, you need to add 1 for 11 times. You see, that's time consuming in an exam room. But if you do it like this, if you take that number, put it in your calculator, you take a square root of 70 like this, put it in a calculator, and then you sort of, okay, see, okay, it's between 8 and 9, then you're good. Take, for example, moving from 63 to 49. so that you can get 7. It's gonna take you forever. So you must prefer the easiest way, right? All right, let's try the last one, then we are done. It says square root of 150. Why not? It's coming our calculator. And let's say square root of 150 equals to, you get 12.247. You know 12,247 blah 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 is greater than 12, but is less than 13. 12 times 12 is 144, right? So that means is square root of 144 is less than square root of 150 is less than square root of, what is 13 by 13? I think it's 169. 13 times 13 equals to, yes, it's 169. 169 here. So you're gonna say, okay, 12 square root of 150 is greater than 13. Just like that. Always remember your numbers that your consecutive integers lie between. They always going to follow each other, right? So after watching this video, you shouldn't fail any question that says you find the two consecutive integers. It should be straightforward, right? If you have any question, please leave it in the comment section. I'll be ready to answer it.